Welcome to One Chemistry. In this video, we are going to see Crams rule. We will see basics, mechanism, and problem behind it. It is a stereoselectivity concept, very important in terms of competitive examination. Stay tuned. Here I given references for your examination. Crams rule and anti-Crams rule facts are given. Crams rule basically about position of large group and CO. Anti-Crams rule based on Z group, that is coordinating group, and CO. I given group of chelating agent, non-chelating agents. So better you memorize this to solve the problems. First we will go by the basics. Why the Crams rule is needed. In normal nucleophilic addition, one nucleophile is there, carbonyl is there, you are attacking. If there is no chiral carbon near the position, that is alpha position, you will get mixture of enantiomer, that is 50-50, mostly racemic, no major or no minor. If it is chiral present mean it is very interesting. You have only one product, that is less hindered side attack product. Here one chiral center makes the difference and create the selectivity and diastereomer selectively form. This concept is explained by Cram. The rule is called Cram's rule. Now let us see what is Cram's rule. In carbonyl system, if there is any alpha hydrogen which is chiral one, then Cram's rule will apply. The stereochemistry is important here because product and starting material both have stereochemistry. The nucleophile attacks where the less hindered position. Normally you carry with the large functional group. Here pH can attack similar side of large group, that is C2H5, or opposite side of large group. It will result in pH below the plane or above the plane. Here above the plane is major. We will see that is why. Here important thing you should notice is prochiral center become chiral center. It is diastereoselective synthesis or more simply asymmetric synthesis. Here position of aldehyde, that is carbonyl, and large group, that is bigger in chiral molecule, decide the product. Here going by the mechanism is hard. Better you know the trick to identify the product. First step you should do the relation between the large group and carbonyl group. Large group is the bigger group in the chiral carbon, that is phenyl. Be careful, bigger group, not the higher priority group. The bigger group and carbonyl relation should be whether syn or anti. If it is syn, attack will be happen on medium side. If it is anti, attack will happen on small side. It is easy to memorize. You just do an abbreviation LACE. LACE mean large group, anti, small side attack. It is like LACE ships, so don't forget large group, anti, small side attack. This will help you to answer the problem very quickly, particularly PYQs. Here I want to give important note on anti-group. You should find the position between carbonyl and bigger group. In first one, just a rotating carbon. In both case, it is anti. It is just rotated, but position is same. In the second one, you just see it is syn. Even though it's look like anti, it is syn position. In third one, carbonyl and bigger group, both are in anti position. Fourth one, both are in syn position. These are all variables. Just look and master yourself what will be really. The seventh one is very interesting. There is no clarity because CHO written combined. In that case, don't get confused. Question may be wrong or you don't understand the question. So the master the anti-periplanar position. Then one more note, why the alpha position? If it is in the alpha position, the steric effect is effective. You get selectivity. The first example, if you see carbonyl group exactly in alpha position, you have stereoselectivity. On the contrary, if it is away from the carbonyl, say delta or above the delta position, you don't have the selectivity. Chiral carbon should be in alpha position, then only Cram's rule will be applied. Here I given Cram's model. or rule. It is just simple. You are viewing in the steric point of view. If you look at large, medium and small group, obviously large group handy to CO, that is our understanding. Then attack will happen between small and medium. Small is very preferable because incoming nucleophile come with electron, so repulsion is maximum on the medium side. So only happen on the small side. There where the stereoselectivity comes, you have final product. I would strongly recommend don't go by the mechanism. Just use the trick, find the product. Then we are coming into the more useful thing, that is how to find the product or how to achieve the selectivity. First step is you just find Crams rule or anti-Crams rule. It based on the fact that whether it has coordinating group or not. Here our focus is Crams rule. Let us assume you go by the Crams rule. Then find the large group, medium group, small group in alpha chiral carbon. Then find the CHO relationship with large group. Then use our table, that is trick table, to find the product. Write the final stereochemistry. Then very important thing, don't get confused between grams and antigrams, and don't forget the exceptions in antigrams. Then we are moving into the very important thing, problems. Problems are best way to learn, best way to understand, best way to master. That's why I suggest you master the problem solving, then only you master the concepts. Let us see the first problem. You have carbonyl, that is aldehyde. Alpha position, you have chiral carbon. CH3 above the plane, hydrogen below the plane, cyclohexane on the plane. You are heating it up. Methyl magnesium halide you are using, that is Grignard reagent. You should find what will be the final product. Here, by looking at the carbonyl, alpha chiral carbon, you might realize it is the Crams rule. So we will go by the basics. In chiral carbon, large group is cyclohexyl, medium is methyl, smaller is hydrogen. Here large group is our interest, whether it is syn or anti to carbonyl. Here if you look at it, both are in the same plane, same side. So it is syn position. Large group and CO syn mean attack will happen on medium side. Here medium group is above the plane. So CH3, that is incoming nucleophile, attack above the plane. You have the final product. The concept you have to learn here is you should be master in identifying the large group. Then the next example, here you have aldehyde. In alpha position, you have the long chain with chiral carbon, methyl above the plane, hydrogen below the plane. You are using heat and lithium aluminum hydride. You should find what will be the final product. Here carbonyl group is there, and in alpha position there is no chirality. The chirality is in the long position, that is very far from the carbonyl. So no selectivity. OH can be above or below, mostly mixer of product, that could be racemic. The chiral compound should be in alpha carbon, not in any other position. Since there is no alpha position chirality, no selectivity, no steric effect, Crams rule is not applicable. So the concept you have to learn here is the chiral center should be on alpha carbon. Then the next example, the starting material is ketone. One side methyl group, another side you have chiral carbon with hydrogen above the plane, methyl below the plane, tertiary butyl group is on the plane. You are using ethyl magnesium halide and heating it up. You should find what will be the final product. Here the compound is stereochemically specified, the chiral carbon in the alpha position. So we should label the compound which is large, small and medium. Here large group is obviously tertiary butyl group, small group is hydrogen, methyl is medium. The relationship between CO and large group is syn. So attack will happen on medium side. Here medium group is below the plane. So the incoming ethyl group should attack below the plane. So final product, methyl attacks below, that is nucleophile on below position, below plate. You have the final product. Then the example 4. In Saha's description, hydrogen, methyl, phenyl in clockwise position. Another side you have carbonyl with methyl. You are heating it up. Lithium, aluminum hydride you are using. You should find what will be the final product. Here starting material is interesting. Stereochemically specified in Sahar's position. Don't get confused. Go by the basics. Identify large, small and medium group. Large group obviously phenyl. Medium is methyl. Smaller is hydrogen. You can clearly see phenyl and carbonyl in anti-periplanar position. Very clear. If you look at the table, large group and carbonyl in anti-position mean attack will happen on smaller side. Here smaller group is hydrogen. So attack happen on the hydrogen side. So attack happen. Both hydrogens are similar. You have the final product. So you should master all stereochemical description. Then the next example, starting material is ketone, one side methyl group, another side methyl group, hydrogen above the plane, long chain propyl is given, phenyl magnesium bromide as the reagent. You should find what will be the final product. Here alpha position there is chiral carbon and carbonate, definitely Crams rule. So we should label the compound. If you want to label, large functional group is propyl, medium is methyl, hydrogen is smaller. So the relationship between large group and carbonyl is syn there. So if you look at the table, large group and carbonyl syn mean attack will happen on medium side. Here nucleophile is phenyl. The medium side is methyl position which is below the plane. So phenyl attack below the plane. So methyl and phenyl below the plane. You have the final product. The concept you have to learn here is you should master the large functional group.